Hello everyone, I am Zulaikat Faima of CSC Cybersecurity Department, pursuing my education in Sri Venkateswara College of Engineering, Bangalore. I am here to talk about the topic in theory of computation, that is the pumping lemma for context-free language. Let us see the introduction to pumping lemma. The pumping lemma is a fundamental property of a context-free languages. It provides a technique to prove that certain languages are not context-free. Understanding this lemma, it is crucial for distinguishing between different language classes. Here we can see the pumping of a regular set theorem. So this theorem states that let L be a regular set, then there exists a constant n such that for every string W in L, and here given the statements. Now let us see about the context-free languages overview. Context-free languages are generated by context-free grammars. They can be recognized by pushdown automata, a type of computational model. Examples include programming languages and certain natural language constructs. So let us see context-free grammars. In this section, we shall introduce context-free grammar to generate a class of languages larger than the class of regular languages over the same alphabet. Now let us see about the importance of the pumping lemma. The pumping lemma helps in analyzing the structure of context-free languages. It is used to prove the non-context freeness of specific languages. This lemma is essential for theoretical computer science and formal language studies. Now let us see the statement of pumping lemma. The pumping lemma states that for any context-free languages, there exists a pumping length. Any string longer than this length can be divided into parts that can be pumped. Pumping means repeating certain sections of the string without leaving the languages. The statement of pumping lemma is given here. Now let us see the components of pumping lemma. A string can be divided into 5 parts, that is u, v, w, x, y. The conditions requires v plus x should be greater than 0, ensuring that at least one of the parts is non-empty. The string must remain in the languages when pumping v and x any number of times. Now let us see the condition for pumping. The segment v and x can be repeated any number of times, including 0. The result of the pumping should still belong to the original language. This property must hold for all possible strings within the languages. Visual representation. A visual representation can aid in understanding the structure of pumped strings. Diagrams often illustrate how strings can be split into U, V, W, X, Y parts. Visuals emphasize the flexibility of repeating sections while maintaining the language memberships. Now let us see example for the pumping lemma. Let us consider the context-free language L is equal to a to the power n and b to the power n, where the condition n to the power greater than or equal to 0. For any string in this language, the pumping lemma can be applied. The string can be divided and parts can be pumped while remaining within L. Non-example of pumping lemma. A classic non-context free language, that is L is equal to a to the power n, b to the power n, c to the power n, where n is greater than or equal to 0. It can be shown that no matter how you divide a string from L, pumping fails to keep it in L. Such example illustrate the limitations of the context-free languages. Now let us see the proof structure using the lemma. To prove a language is not a constant free, assume it is applied to the lemma. Find the string that cannot satisfy the pumping conditions. Conclude that the assumption of being context-free must be false. Applications of pumping lemma. The pumping lemma is widely used in the theoretical computer science of language classification. It can help to identify languages suitable for specific computational models. The lemma plays a crucial role in compiler design and language processing. Limitations of pumping lemma. The pumping lemma cannot prove all non-context free languages are not context free. Some languages may satisfy the lemma but are still not context free. This emphasizes the needs for additional tools in the formal language theory, related theorems and concepts. Other important concepts in formal languages include Chomsky hierarchy. The relationship between context-free languages and regular language is significant. Understanding the closure property is also essential for the language classifications. Now let us conclude this by the pumping lemma is an essential tool in understanding the context-free language. It provides a systematic way to prove non-context freeness of certain languages. Mastering this lemma is a vital for students and professionals in the computer science.